Be the function defined above. Find the average rate of change of f on an interval -3 less than or equal to x less than or equal to 12.
So we're looking at average rate of change. That's basically our slope. So we have the endpoints are given to us, f of 4 minus f of -3 over 4 minus of -3. And yes, you have to show all that part, okay? And then we're going to plug it in. When we have f of 4, I need to plug it in for the bottom function. So we have f of 4 is equal to -4 plus 3 cosine of. So if I plug in 4 into this parentheses, that's going to give us what pi? 2 pi. And then let's compute further. -4, then I have my 3, and I want to focus on this guy right here. 2 pi is located here, and the order pair of that is 1, 0. Is my cosine the x or the y movement? It is the x. So we have times a 1. So that tells me my f of 4 has to be negative what? Very good. So here's my -1 minus. Now for -3, I'm going to plug it into my top function. We have f of -3 is equal to square root of 9 minus, parentheses is a key. So when I square the -3, what number do I get? And then 9 minus 9 is? Square root of 0 is? 0. And then we have 4 minus a -3, that's technically plus the 3. That gives us what? 7. So our final answer is -1 over 7. Okay, let's talk about how they're going to actually give you the credit for the FRQs. Every FRQ is 9 total points. This one has 4 parts. Okay, so some of them is going to weigh more and some less. Getting to a -1 over 7 is going to be 1 point. But yes, you have to show all the work pertaining to that. All right, let's move on to the next one. Let's go to part B. Okay, let's read part B.
Write an equation for the line tangent of the graph at x.
Okay, so it says at x equals 3. So first of all, we know we have 3 is our x1 piece. For x2 piece, not x2, y2 piece, did we already compute that a while ago?
Yeah.
Did we already?
No.
No, we didn't. So when x equals 3, we're going to go up here. I have -3 somewhere. Can someone point out where I got -3 from?
It goes in the second equation. 3.
It goes in the second equation. Very good. So on my second equation, since x pertains to this range, oh, you can't see. My x equals 3 goes into that range. We're going to plug that into my second equation. So that's going to give us -3 plus a 3. That's a 3. My hand's still struggling. Cosine of 3 pi over 2. So then, my main focus should be this one for now. So as a reminder, 3 pi over 2 is down here. The order pair is 0, comma what? -1. And cosine is the x movement. So really, in the end, all that becomes 0. And that's where the -3 came from. That would be our y1 piece. And then now I need our slope. M is equal to. So for my slope, I need to find the derivative of that function. So let's write in f prime of x is equal to, what is the derivative of -x? -1. And our derivative of cosine is what? So it'll be -3 sine of pi x over 2. And are we looking at chain rule here? And then we derive the inside. When I derive the inside, pi is a number. So when I drop the x, we have pi over 2. So let's kind of further compute. We have at f prime of 3, -1 minus 3, sine of 3 pi over 2 times pi over 2. So we're just substituting in. So I want to focus on this guy right here. Sine of 3 pi over 2. Didn't we already mention something over here? So we have -1 minus 3, and all that is going to be -1 times pi over 2. And when I combine like terms or simplify, negative 1 plus 3 pi over 2. That alone is a slope. So I'm going to write out that is my slope. And then we're going to apply point slope formula, basically the algebra 1. So it's going to be x minus the x, or y minus y1. So how would I write y minus y1 with a negative? Plus 3. And for my slope, leave it fancy like that. You can't combine like terms anyways. So that's my m, and x minus x1 is going to be x minus 3. So then, the way the AP graders are going to grade, finding the slope is 1 point, and writing it in this format is 1 point. So how many points has been taken account for so far? 3. 3 total. So then let's go on to part D. Okay, Kylie, go ahead and read part D, please.
Must there be a value of x at which f of x attains an absolute maximum on the closed interval negative 3 is less than or equal to x is less than or equal to 4? Justify your answer.
So if there's a maximum, the graph should be continuous or not continuous? Should be continuous. If y'all remember the extreme value theorem, it basically states, as long as the line is continuous, there is a number at the very max and a lowest point as well, which is called the absolute minimum. So all we have to prove is the fact that our common number is continuous. And by that, I'm talking about, it'd be nice if this was printed on there too, but what x value is common between these two intervals?
0.
So when I plug in 0 into the first function and 0 into my second one, the end result of the y value must be identical. Then I'm proving that they are continuous. So let's check. So let's write on here limit as x approaches the 0 from the left, and the limit as x approaches 0 from the right of the function must be identical. And I'm going to plug in that function. The first one was a square root function. And it was 9 minus x squared. So in our case, it's going to be 0 squared. And that's going to lead us to what number? 3. And then for the second one was the negative x, so negative 0, plus 3, cosine of 0 pi. And let's do a quick reminder on 0 pi. Here's my 0. And that's at 1 comma 0. So cosine of 0 pi alone is how many?
1.
So that's going to give us 0 plus just 3. And that's going to lead us to the same number. So is it continuous?
Yes.
So I'm going to put on here, it is continuous. And of course, justifying, they do want that in a sentence. So let's write on here, because f of x is continuous on the interval given, negative 3 to what? 4? That's a bracket, ugly bracket. Extreme value theorem guarantees that f of x attains, and I'm using this exact word phrase that's on the question, or in the question, attains an absolute maximum on, again, closed interval 3, negative 3 to 4.